Okay, most students lose marks on buffer questions because they memorize definitions but don't explain equilibrium properly. So let's fix this. Let's read the question carefully. Healthy human blood cells need to maintain equilibrium of 7.40 for the body to function. Carbonic acid H2CO3 is a weak acid and produces HCO3 ions, act as a buffer to maintain the pH. The pKa value has been given, which is 6.38, and they said this is important. Explain in terms of equilibrium how carbonic acid and hydrogen carbonate mixture act as a buffer. And they are then asked you to calculate the ratio of them. Okay, so there are two parts to this question. One is to explain equilibrium, and second one is to give the ratio. So two parts for 6 marks, so 3 marks each. Okay, so the first step is to write the equation. So H2CO3, which is a weak acid, so it will be in equilibrium. Always remember, all the weak acids are in equilibrium. Okay, and this breaks down into or dissociate partially into these two ions. And this is the whole key to the explanation of this question. And you just have to need to talk about the shifting of equilibrium. Now, what happens if you increase if you add some acid to this equilibrium? What will happen? Now, answer that if you add acid, you know that acid releases H plus ion, right? And these H plus ion, and you know how equilibrium works as well. So if you increase these ions, they go up. The equilibrium tries to reduce them by shifting it towards this side, meaning H will react with HCO3 to make more of H2CO3, isn't it? So then you will write your explanation that if acid is added, the equilibrium, the wordings has to be very precise to gain the mark. The equilibrium shifts to the left. Why? To reduce H plus. Okay, yeah. And one to reduce H plus, you just have to just then write the equation what is happening. So you just write this plus this. So H plus will combine with HCO3 1 minus, making H2CO3 as your product. And this is what is happening. And this is how you are reducing. And you're telling your examiner that this is how H plus ions are reduced. Now you need to talk about if you add alkali, what happens, or a base, right? And we know that alkali releases OH minus ion. So what happens in that case? That the equilibrium OH minus ion. Now there are so many OH minus ions are being given that they would start reacting with water molecule to H plus ion. And what will happen? They both react. So you're removing H plus ion. So equilibrium shift in that way. Okay, to counteract the change or to increase the H ion concentration, if that makes sense. Okay, now remember H plus ion reacts with OH minus ion. So what you will say, this, if you add alkali, this will remove H plus ion. Why? Because they are reacting together to form water molecule. So equilibrium shifts to the right to replace it. To the right to replace it. To replace it. Okay, so more H2CO3 will dissociate to produce H plus ion. Now we need to do the calculation. So the key thing that you can say in one line as you might find in the mark schemes as well, that the buffer solution resists pH change because equilibrium shifts to oppose any change in the H ion concentration. Okay, now let's talk about the calculation part of it. Now, what the question is asking you is to work out the ratio of these two ions using, now what you have been given, so I'm just going to circle that as well. What you have been given is this. You have been given pKa value, so you can work out the value of Ka by using pKa, and you've been given pH value, so you can work out the H ion concentration by using pH. And how, I'm going to explain now. So let's do the calculation part. You know that the if you have a weak acid, just like this one that we have in here, if you have a weak acid, the dissociation Ka is the acid dissociation constant, and it will be concentration of H plus ion and concentration of your hydrogen carbonate ion, and you just divide that by the acid concentration, right? This is what you know. Now substitute the value. We know what pKa is. pKa is given as 10 to the power pKa value has been given as 6.38, right? No, that's apologies. No, this is not pK. This is K. It's okay. So pKa Ka is given as 6.38, right? So what you can do is to work out Ka, which is equals to 10 to the power minus 6.38, and that gives you 4.17 into 10 to the power minus 7. So you got your Ka value, and you're going to be substituting that in the equation. So the next step would be this. Use now the pH, which is equals to 7.40. So that you know that pH equals negative log of H plus ion concentration. Therefore, your H plus ion concentration would be equals to 3 point. You just do the calculation, which is 10 to the power minus 7.40, which is equals to 3.98 into 10 to the power minus 8. Okay, so you got the H ion concentration. Now you're going to rearrange your equation. What was the equation you had? That Ka equals the concentration of H plus ion and HCO3 minus ion over H2CO3 concentration. Okay, so now you're going to rearrange this and work out the ratio. So simply what you would do is this. You need the ratio of these two according to, I'm just going to go to the question quickly to show you the ratio part. This is the ratio you need, concentration of this and this, okay, the ratio of these two. So I'm just going to make sure that we get the ratio correct. So I'm just going to rearrange the equation, and I would say Ka over H plus ion concentration equals HCO3 1 minus, which is going to remain as it is, and H2CO3 concentration. Okay, and just put in the value. pKa you worked out 4.17 into 10 to the power minus 7 over, and the H ion concentration is 3.98 into 10 to the power minus 8, and that gives you 10.5. Okay, so that's your answer. So you'll have to say in the form of a ratio. Ratio equals 10 to the power minus 5 over 1, or is to 1 actually. Just say is to 1. Okay, to get full marks, you must do two things: explain equilibrium shifts clearly and show the correct calculation. Okay, thank you very much. I hope this makes sense. Thank you, and let me know if you have any question.